In this video, we will learn to design a tooling set of die and punch used to transform a flat sheet into a cylindrical container, something like this. In this video, we will go through typical workflow of mechanical designing. So if you are a beginner, this video is a perfect example of how to design a tool from completely scratch. So the first step of designing any machine or any tool is to gather all the necessary input information and required data. And the key input information we need is what is the primary function of the machine or the tool. So in this case, as I mentioned earlier, we need to design a tool that will transform a flat circular sheet into cylindrical container with a flange. And the process of shaping a flat sheet into a desired 3D shape is called drawing process. And to perform the drawing process, especially deep drawing process, a higher amount of force requires. So we will use a hydraulic press to operate the drawing tool. In our case, the calculated drawing force is 13.5 ton. But considering additional factors like friction during drawing, we will use a press with a 20-ton capacity. However, in this video, we will only focus on the tooling design, not to the press design. And the data we need to design the drawing tool is the final product design or its drawing. In this case, we have both the 2D drawings and the 3D model of the container of the final product. Now, here is an important point about input data. First, always try to get CAD data in universal format like STEP, IGS or Parasolid. This way you can open the file in any CAD software. Also, the version doesn't matter. Second, even if you have 3D model of the final product, you still need 2D drawings because 3D model doesn't contain dimensional tolerance. And for tooling and fixture design, the dimensional tolerance and GD&T are very crucial. But in our case, the tolerance doesn't matter, it's just a container. So the final product dimension after the drawing process are the depth 60 mm, inner diameter to be 160 mm, flange width is 20 mm, and the sheet thickness is 1.2 mm. The flange and bottom corner radius are 8 mm, to be maintained by die and punch edge radius. And before the drawing process, the blank size, the flat circular sheet, has a diameter of 280 mm. Now, if you're wondering where these values come from, like blank size diameter or required drawing force 20 ton, so I have already covered all these calculations in this video, where I have explained everything about deep drawing process, including blank size, drawing force, drawing limit, punch radius, die radius, and die clearance, 0.12 mm in this case. So if you want to master the drawing process, check out this video later. Now, as a beginner designer, after understanding all the input information and collecting all the data, they might jump straight into the CAD software and start designing. But a pro designer doesn't work that way. First, we create a concept using pen and paper. We plan every steps, where to start, where to end. And once we have the clear path, a clear roadmap, then we start designing. Because any design, whether a machine, a tool, or even a painting and art, never finalizes in a single step. We first sketch the outline and then we refine it and then finally paint our multiple layers. And this is same with the machine design. First we made a concept, a rough concept, and then we model it in CAD software. We adjust all the dimensions and then we refine the design and finally we optimize it. And then finally we add all the details like hole, thread, connections, dowels. So let's start with the concept design. Here I'm going to use a tablet, but most of the time I use pen and paper. So here I have drawn this cross-section view of the final product, the cylindrical container after the drawing process. So the die and punch will be the counterpart of this shape, something like this, right? But we need to understand that this is the final product after the drawing process. Initially, the seat was just a flat circular blank, right? So first we need to place this blank seat over the die, something like this. This means the outer diameter of the die must be at least the same as the blank size, which is 280 mm in our case. Now, once the blank is in the position, the punch will come down and will draw the seat into the die. But here's the problem. When the punch starts drawing the seat, the metal nearby the die solder will begin to deform unevenly, causing the wrinkles due to the hoop stress around the die solder. I have explained this defect in detail in this video. So to prevent the wrinkles formation, we need to keep pressing the blank in the place during the drawing process, while allowing the punch to draw the seat into the die, right? So for this, we need to use a blank holder plate. And to apply the force to the blank holder, we can use mechanical spring or a hydraulic cylinder or a pneumatic cylinder or a gas spring. For lighter application, mechanical springs works fine, but for a heavy multi-stage deep drawing, we usually prefer to hydraulic cylinder or the gas spring. And in high precision deep drawing, servo press are also used. Now, how much force should blank holder apply? So typically the blank holder force is 20% to 50% of the drawing force, depending on the material property, seat thickness, and other factors. So this can also require a trial and error method, but if you have no previous experience, a good starting point is 33% of the drawing force. So in our case, the drawing force is 13.5 ton. So the 13% will be 4.5 ton, around 4500 kgf, or in Newton, it will be 44100. And in this design, we will use gas springs to apply this force to keep the system compact. Now, if you say, why not just use the mechanical compression spring? Why the gas spring? So here the biggest disadvantage of a mechanical spring is the force variation with compression. As a mechanical spring compresses, its reaction force increases and reach its full capacity when it's fully compressed. So at the starting of the drawing process, it might not provide the enough force, which can lead to the defect, the wrinkles defect. Now, the gas spring on the other hand provide an almost constant force throughout the pressing stroke. At the starting, gas spring delivers like 80% of its full force, and when it's reached the 100%, it's fully compressed. Whereas mechanical spring go from 0% to 100%, which is not ideal for the deep drawing process. So for heavy drawing process, gas springs are better choice as compared to mechanical springs. So we will mount the multiple gas spring above the blank holder plate to evenly distribute the force. This way, when the press starts, the gas spring will apply a constant holding force, ensuring a smooth and defect-free drawing process. Now, everything is in the place and we can move to the detailed designing. But before that, let's think ahead. What if in future, if we want to automate this process completely? Imagine using a automatic loader to place the blank seat and keep sliding the final product after the drawing. So with this current tool design, this won't be easy. Why? Because the final product sits inside the die after the forming. So we cannot simply slide it out. Even if we want to manually collect the part from the die, it won't be easy because it sits inside the die. So one solution is use an internal ejector within the die to lift the product and then slide it out, or take it out. But it has a major drawback. It could damage the finished part because the seat thickness is only 1.2 mm, especially if the ejector force is uneven. So a better approach is, instead of ejecting the parts from inside the die, is flip the setup upside down. Here what this means: if I upside down this concept, then the die will mounted on the upper moving plate of the press attached with the main hydraulic cylinder, and the punch will be fixed on the base plate. Now here, the punch stays fixed and the die moves downward to form the seat, and the blank holder plate sits around the punch at slightly above the punch tip, the top surface. And again, the blank holder is supported by the gas spring mounted below the base plate. So this setup ensures that once the forming process is completed, when the die goes up, the final product remains on the blank holder plate, which is very easy to collect it or just slide it. I know this seems a little confusing, but this will become even clearer when we go into the CAD design. So let's start the designing, and we will refine the concept as we go further. So now we are in SolidWorks, and if you want to follow me along, you can download the CAD model, required CAD models from the video description. So now first let me create an assembly. And first let me bring our final product into the assembly. So go to the insert component and insert the final product, our container, after the drawing process. Now the part orientation is as it should be, but as we are going to use our tool in upside down direction, so first let me rotate this component into upside down direction. And to do that, first let me set it to float. Okay, and now we can rotate it. And now we have to also fix it in that position. And to do that, let me select the top plane of the assembly view and the top face of our container of our final product. Okay, and same with the front plane. So let me select the front plane of the component. Let's bring it back. Also same with the right plane. Coincident actually. Now our product is fully constrained and this is in the position. Now just for visualization, let me also bring our blank size. Okay, so let's bring it here, and also let me mate it with our final product on a same level. Okay, and also let me concentrate it with our final product. Okay, now we can see initially this will be a flat seat, and then after drawing this will be take this container shape, right? Now before designing any part, first let's decide the sequence of designing, like what will be our first part and then what will be the next part. Okay, and let me quickly recreate the same concept that we have discussed earlier, and then we will decide the sequence. Okay, draw our punch and the die outer diameter. Okay, the size, the outer diameter size will be the diameter of the blank size, right? And there will be a cavity for our product, something like this. Okay, now we will have our blank holder. So blank holder will be somewhere here, which will support our blank size, flat blank size. And we will mount our punch over the base plate. So let me also draw the base plate. So base plate will be somewhere here. Okay, and we will mount our our punch over the base plate. So this is our base plate. Okay, and we will support our blank holder using the gas springs, right? Something like this. Now our die will be also mounted over a plate, over a pressing plate. and the pressing plate will be attached with our hydraulic cylinder. But first let me draw a guide here. So there will be a bush over the pressing plate, right? Something like this. I know this sketch is not good, but just assume this will be our bushes, and there will be a guide. Okay, LM shaft will be there, and we will use 4 LM shaft, LM guide to move our press plate up and down. And there will be one more plate on which we will mount our hydraulic cylinder. Okay, so this will be our hydraulic cylinder mounting plate. This will be the pressing plate, and the die will be attached with pressing plate. Okay, now let me also draw the hydraulic cylinder. Let me take another color. Any color will be fine. So there will be our hydraulic cylinder. This will be the piston of the hydraulic cylinder somewhere, and this will be mounted with the pressing plate. Okay, so this is going to be our overall press design, but in this video we will only focus on the tool design. Okay, so which part we can design first? So I would like to start with punch design, because this is very easy. We have all the dimensional reference, the dimension of the final product, and the punch is just a counterpart of the final product, the inner counterpart, right? And then we can go for designing of our die. And then lastly, we will design our blank holder. And then we can see how we will mount this blank holder with the gas spring, and how we can mount our gas spring with the base plate. So let's start the designing of punch. Okay, so let's create a new part. And here, either we can use extrude command to make the punch, or we can use the revolve command, but I'm going to use extrude command. So let's select the sketch and select the top plane, select a circle and start from origin. Oops, I missed it. So set it to origin and set the dimension, the diameter, to 160 mm. Why 160 mm? So our product inner diameter is 160 mm. Okay, and punch is going to be something like this inside the final product. Okay, and let's take the extrude command and the height. So our depth of the final product is 60 mm, so set it to 60. Okay, now we need to take a step right here. Okay, so let's take a sketch again and sketch on the bottom face of the punch and select a circle, start from origin. And now what would be the diameter of this step? So if you see the drawing of the final product, so the outer step diameter is 200 mm. So for now, let's just set it to 200 mm. Maybe we need to adjust it later. Okay, now close the sketch, go to the feature and select extrude. Now what we can set the height of the step. So for now, let me take it to 20 mm. We will adjust it later, definitely. Now the radius is, okay, and this is very important in a drawing of, for the drawing process of the seat that I have explained in our previous video. Now the radius of the punch at the top tip is 8 mm. Okay, and at the shoulder position, at this position, is actually 9.2 mm, not the 8 mm, because 8 mm is the outer radius. The inner radius right there is 9.2 mm. Okay, so let me select a flit command and select the top edge and set it to 8 mm. And for shoulder area right there, set it to 9.2 mm. Okay, now we can save it with the name of punch. Right, now what would be the material of the punch? So generally for production tool design, we select the material like D2. Okay, it's a carbon, a chromium series tool steel. So let's select the material, but here there is no such tool still, so let's try to find it in a edit material section. And in this section you will find this. There is a tool steel, but this is A2, the tool steel, which is especially designed for the air hardening. But we don't need air hardening, because air hardening is used for generally complex shape tool design, but for production D2 is better. Okay, but as we have no any option, so let's apply it, but we will change it in our manufacturing drawing. Okay, so let's apply it and save it. Again, it's already saved, so let's go back to the assembly. Now the second component we can design is our die. So, and die outer diameter is going to be blank size diameter, right? So let's create a new part. Go to the sketch, select the sketch, select the top plane or whatever plane, select a circle because it's going to be circular, cylindrical, right? And start from origin and set the outer dimension, outer diameter to 280 mm. I don't know why I'm saying dimension instead of diameter. Now set the height. So what would be the height? So as we know, the product depth is 60 mm. So of course there will be 60 mm. Plus we need to left some material over the cavity. Okay, so let's try to add 20 mm, so it would be 80, or we can go for 100, that's also fine. Okay, we will adjust it later, right? Now select the sketch and select this plane and try to make that cavity of the final product. And the final product outer diameter is not defined in this drawing, but we can see 160 is our inner diameter, and then we have the seat thickness, which is 1.2 mm. Okay, on the both sides. So let me set it to 160 plus 1.2 on the left, 1.2 on the right. But here we have to also add the die clearance, which we have calculated in our previous video, and that was 0.12. So in this case we will have to double it for the both sides. Okay, so this is 162.64. okay, now close the sketch, go to the feature and select extrude cut. Okay, and the depth we are going to set is 60. Maybe we will have to check it, or maybe we will have to adjust it, but later. Okay, and now let's save it with name of die. Okay, and again the die material is going to be D2. Now the radiuses. Okay, so here you can see the radius. Let me take a snapshot so it will be easier to visualize. Okay, so let me take a snapping this thing. Okay, and let me draw the die here. Okay, so our die is going to be something like this. Okay, something like this. Okay, now the radius here is 8 mm. So this shoulder radius is going to be 8 mm, but this outer at the top of the die is going to be 9.2 mm. Okay, because the seat thickness we will have to add into the radius. Okay, so let's select the flit command and set this dimension, the shoulder radius, to 8 mm. Right, select it again and set this dimension to 9.2. right? Now before going to design the blank holder, first let's bring both things, the punch and die, into the assembly, and then we will simulate and then see how we can design it. Okay, so here I'm going to insert component and select the both the die and the punch and bring it into the assembly. Okay, now first let me quickly meet this thing, or let me first hide this sketch, meet these both with that our final product. But as you can see, both all have the same color, so it's very hard to visualize. So let me first set the different appearance for these products. So for final product, let me set a color of any color we can set, but let me choose the green. Okay, it's yellow, I don't know, let me select the green. Okay, and let's save it, right? And for blank, let me set it to yellow. Okay, oops. So go for the appearance and set it yellow from right here. Now first let me concentric the both things, but this is sketch also we need to hide it. Let me hide it. And so first select the both faces, and you will get this pop-up menu of mate. Okay, so here we can set it to concentric, or you can also go to the matte and then you can choose the matte properly. Now select these faces and oops, and also we can do with the die right there. Okay, now take a cross section and let's see how it works. So initially our blank will be right there. Okay, and the die will become from the top and will start forming the blank into this shape, and finally we get this thing, this container. Now where will be our blank holder? So we can see our blank holder will be here to support our blank, right? But let me hide this concept and let me only focus on the blank holder, and let me redraw the blank holder. So initially the blank holder will be at the top, right? Somewhere here. Now this seems as an individual part, but we know this will be a ring, circular ring right there. Okay, and will be supported by our gas springs. Now when this die will be come down, let me exit and let me draw it. So the blank holder will be also come down. I'm not able to pull this sketch, so let me show you the end, what will be happen when it's completely formed, final product. So the blank holder will become as much down right here. Okay, something like this. Now as you can see, there is no much space between the base plate, because base plate will be right there. We'll mount our punch over the base plate, so there is no such a space for a gas spring mounting, right? So what we can do is we can increase the height of the punch. How? Something like this. Okay, so we can increase the height of the punch, so we will have a space for our gas spring installation, right? Or what we can do is we can make an individual part a spacer right there, and that is the better option. You know why? Because if you increase the height of the die, so your cost will be also increased, because the die material is going to be a D2, which is very expensive, and we are also going to be heat treatment over our tooling components. Okay, so as much we can minimize the size of our main components, that will be better. Okay, so let me first quickly design this spacer. So go to the new part and select the sketch, select any plane. Let me select the top plane and take a circle from right here, and start from the origin and set the outer diameter to 200 mm. This is the outer diameter of the punch, and let's close the sketch, go to the feature and extrude it. Let's say 50 mm. We will adjust it later. Okay, now let's save it with name of punch spacer, or we can say punch shoe. Actually this is a die and tool technical term. The part where we mount our punch, we call it punch shoe, and the part where we mount our die, we call it die shoe. Okay, so let's save it. Now what about material? So we can set it to MS, the mild steel or plain carbon steel, right? And let's save it. So let's close it and let's bring it into the assembly, and let me position this with our punch, right? And let's also coincident the both. Now here we have to understand one more thing, that in a die and punch design we must have to align the die with the punch, right? And to do that, let's say there is our base plate below the spacer, below the punch spacer, and there is a pressing plate above the die where we will mount our die. Okay, and there will be a guide rod, right, with guiding bushings, 4 bushings. Okay, let's assume this is our guide rod, or you can say guide shaft, LM shaft, right? And there will be our bushings, which will be precisely guide our pressing plate up and down movement, right? Here what we have to do is we have to must align this punch with the die, and to do that, to achieve this alignment with all the variations, because there will be variation in this plate, in base plate, everywhere. Okay, so what we can do, or what we generally do, is we fix one thing. Let's say we fix our punch and this punch spacer with the base plate with a doweling, of course, or a step guiding, right? And we make our die adjustable on X and Y direction, that we can achieve with slotted mounting. So whatever misalignment will be there, we will able to align the die with the punch. Or we can use this kind of T-slotted plates with the clamp, something like this. Okay, so let's first try to fix our punch and this punch spacer with the base plate. So let me hide this component for a moment, and now what I have to do is I have to first mount our punch with this spacer, and for that what we can do is we can use a counter hole right here on a punch, and we can make a threaded hole in our spacer, something like this, and we can mount this with only a single bolt, right? And it will be very easy to assemble and disassemble. And to position it, either we can use dowel pins, maybe we will need to use the 2 dowel pins, okay? Or what we can do is we can make a step right here. We can make a step right here in our punch, and same step into our spacer. Okay, so let's try to do it. And first let's open the punch, and let me take a point into the center. Okay, and let's close the sketch and choose hole wizard from right here and choose counter bore. Okay, and here the socket head cap screw, I'm selecting M8 is fine, and it's automatically positioned in a new version of SolidWorks if you're using 2025. And let's hit OK. Okay, now let's back to the assembly and also make the threaded hole over the spacer. Okay, so let's select the sketch, point on a center, close the sketch, go to the hole wizard and select the threaded hole and select M8 into 1.25 is a standard pitch. And here I am not going to through all, I'm selecting the blind and set it to 20, and the thread depth is 16, right? And hit OK. But I have to also make a guiding step for the punch. Okay, but I had made this threaded hole first. So what I can do is I can lift this bar up and I can make the guiding step right here. Let's say I want to guide step with diameter of 100 mm. It's a very nice number, and close it and set the height of the guiding step to, let's say, 10 mm or 5 mm, doesn't really matter, but let's go with 10 mm. Now if I pulling this bar down, we will get an error. So the error will be probably because of change in plane. So what I'm going to do is I'm going to change the plane of a sketch. And how to do that? Select that sketch and select the edit sketch plane and select this plane, okay, and hit OK. So now everything is fine. Now we can also add a chamfer for easy insertion during the assembly. Add 1 mm of chamfer and let's save it. Okay, and let's get back to the assembly. Now open our punch and let's make the same step, but here we have to extrude cut, right? Let's set it to 100 mm. We will use H7G6 fit for that, and let's select extrude cut. Now as we have add 10 mm of a step on our punch spacer, here we can go for 11 mm, okay, and we can also add the chamfer onto the edge of the insertion, right? So let's add the 1 mm of chamfer right here and let's save it. Now let's back to the assembly and let's take a cross section and we can see how everything is there. But let me first hide these sketches, it's disturbing. Now everything is fine. We will insert a bolt and we will tighten the punch and die, and this is also well guided with the step, okay. Now what about the base plate and how we will mount it? So first let's make a rough base plate size and then we will try to mount there, okay. So let's take a new part and let's select our rectangle tool and start from the origin and set depth of the base plate to 500 mm for now, because our blank diameter is 300 mm, and the length set it to, let's say, 800 mm. We will adjust it later. Close the sketch and select the extrude command. Now what about the height? So I would like to go for at least 80 or 100 mm because this is going to be 20-ton press, and this is based on my experience. And set the material of plain carbon steel, MS, and let's save it with name of base plate, okay. Now let's bring it into the assembly right here. Now how we can mount our base plate with this spacer? So here we not just have to mount it, but we have to also position it with the base plate. So for positioning, I would like to use a dowel pin right here, okay. And for mounting, what we can do is, actually we have two options. First option is make a threaded hole in a spacer, at least 2 or 4 holes. And we can use a bolting from bottom of this plate, something like this. So there will be our bolt, a long bolt which will be tightened into the spacer. And believe me, this is not a good idea. Why? Because whenever we will try to open, disassemble our punch and the spacer, we will need to go beneath the base plate and then we have to loosen the bolt, which is very difficult, okay. So what is the second option we have is, and that is the better option, is we can make a flange over the punch spacer, something like this, and we can make a simple hole right here and we can bolt it with the base plate from the top, something like this, and there will be one double for the positioning. So let's quickly add this flange to the spacer, to the punch spacer, or we can say punch shoe actually, right? So let's open it again and let's select the sketch and this bottom plane and take a circle right here, or what I would prefer is to use offset command, okay. And for the flange, I would like to go for 25 mm of flange. So let's offset this, okay, and let's close the sketch and choose the extrude command and set the height of the flange to 15 mm for now. We will adjust it later, okay. Now we will also have to add the bolting, so let's add the bolts right here. So I'm selecting this plane, this flange plane, and select a center line and start from the origin and go somewhere here and set this dimension to 115 maybe, but it seems not in center. So let's try with 112. Oops, 112. Okay, now it seems this is into the center. Now close the sketch, go to the feature, select the hole wizard, and from here select a clearance hole. So select the simple hole, and from here select the clearance hole. Okay, and here I would like to use the bolt size M10, and let's set it to through all and select the position. Now we can pattern this hole, so let's select the circular pattern and select the direction for this diameter, and select the feature of this hole and set the 4 hole. It's already 4 holes, so hit OK, and we can hide this sketch. Okay, let's save it again. Now we also have to add a dowel pin, so let's select this plane, select a point right here, exit the sketch, select hole wizard, go for dowel hole right here, and let's select the size of dowel 10 mm. Okay, and here I would like to go the set to depth to 25 mm, and it's already positioned, hit OK. Okay, now everything is perfect. So let's back to the assembly, and let's first hide this sketch right here. And now we also need to add the dowel into our base plate. So let's open it, go to the sketch, select the sketch, and select a point right here, select hole wizard, go for dowel hole. There's already 10 mm is selected, and the depth set to the 25. That's fine, it's already picked it, so hit OK. Now go back to the assembly, and here let's select this dowel hole and the dowel hole of our punch shoe, and let's concentric them, right? And also this is going to be met with our punch shoe. Now everything looks good. Now we can design our blank holder. So what would be the diameter of the blank holder? So we are going to design our blank holder. Oops, let me take another color somewhere here. So the outer diameter of the blank holder will be equal to the diameter of our blank size, which is 280 mm, and the inner diameter should be the diameter of the punch, the outer size of the punch, which is 200 in this case. Okay, so let's try to create this ring. Actually this is a ring. So go to the part, select the sketch, and select any plane, top plane, and select 2 circles, 1 and 2, right? Set the outer diameter to 280 mm, the diameter of the blank, and the inner diameter to the 200 mm. What about the height? So for now let's take it to 20 mm, we will adjust it later, or let's go for 30 mm. Okay, it's all up to you. And save it with name of blank holder, right? And what about the material? So we will set the material to tool steel. Okay, let's add to the fabric and apply it, because seat is going to make a friction with this tool holder when it's getting into the die during the drawing process, right? So it has to be hardened plate. Now get back to the assembly, and let's bring our blank holder. Okay, and let's just concentric this with our punch, something like this, and let's take a cross section and let's adjust it and try to simulate this. So that will be our blank holder initially, and then our die will be come down, and then it will start forming the seat, and the die will be goes down as the seat will be start forming, something like this, and it will be goes up to this point. Now there is a problem. Now let's try to add our gas spring right here to support our blank holder, but as we can see there is no much space. Okay, so let's first try to bring our gas spring and then see what we can do here. Okay, so as our total required blank holder force is 44100 Newton, and here we will have to use multiple gas spring, at least 3 gas spring to balance our blank holder plate while it's pressing, right? So let's try to use 4 gas spring. Okay, so we will have to divide the total required force by 4. So this will be 11025 Newton, right? So we need a gas spring which can provide approximately this much force. And here I have already selected a gas spring from Misumi, and the maximum force that can provide is 12998 Newton, which is approximate to our required force. So let me bring that gas spring into the assembly right here. Now here we have to mount our gas spring, but there is not enough space to mount our gas spring because the diameter of the blank holder is only 280 mm, and there is a flange with our punch shoe, so there is no space. But there's one more problem. Let me show you, or let me take a cross section first. Okay, now if let's say this gas spring is supporting our blank holder, and let's say die is forming our seat. Okay, so at this position there is no guidance to the blank holder, but even if we will mount this with the gas spring, there is a chance when this blank holder will be come down, it can strike our punch right here, right? So what I would suggest is we should add one more holder plate of this blank holder. What I mean to say is, what we can do is we can add a plate, a ring, actually a ring, something like this, which diameter will be more than the blank holder diameter, something like this. So in that way we will have a space for a gas spring mounting. We can mount the gas spring right here, and we also do not need to increase the diameter of the blank holder, and we will also be able to guide our blank holder with the punch. So let's try to create this part. So go to the new part, create a part, go to the sketch, select the sketch, select a circle, and as the diameter of our blank holder is 280 mm, the outer diameter, so let's set it to 300 mm for now, and the inner diameter that we are going to maintain with the punch, so punch outer diameter is 200 mm, right? And let's set the height for I'm not sure, but let's go for 50 mm. We will adjust it later. And we need a step for our blank holder, right? So let's take one more circle and set the diameter to 280 mm, the diameter of the blank holder, right? And select the extrude cut, and let's set the depth to 5 mm for now, and let's save it with name of blank holder shoe, and set the material to mild steel, right? We don't have to be harden this plate. And let's back to the assembly, and let's bring our blank holder shoe right here, and let's mate it with our blank holder, something like this. Now also let me hide the markups. and let's set it to cross section view and this normal it. Now, as much it will be required for the gas spring, we will able to increase the diameter of this blank holder shoe. But here I want your attention. How we will be sure that we have placed our blank at the position, into the position, because there is no guidance, right? So what we can do is we can add a step for placement of the blank over the blank holder plate. So to do that, we will need to add a guide, something like this, right? So we will able to put our plate, the blank plate, into a cavity, into a circular cavity. So let's try to add this step into the blank holder. Okay, so let's open it, and now first we need to increase the diameter. So it's a 280 mm and I want 5 mm or let's say 10 mm of the step width. So let me add 20 mm. So it's become 300 mm now, and let's cut blank size to 280 mm, right? Or we can go for 281 mm. The 1 mm will be a tolerance, right, for the blank size. And let's cut the depth of, we can cut it to like 2 mm because the seat thickness is 1.2 mm, but let's take 5 mm for now. Okay, let's save it and go back to the assembly. Now we also have to increase the diameter of the blank holder shoe. So let's select it and increase the diameter by 20 mm for now. Okay, oops, 320 mm, and also increase the step diameter to 300, right? Now the 300 is our new diameter of our blank holder. So everything is set. Now we can place our seat into the cavity very perfectly, and then we can deep draw into the die, right? But now here is a new problem. When we reach the end position right here, so what will be happen is there is no space. Also it's touching the flange. We need to add a bolt here. There will be a bolt head, something like this, right? So we need to increase the height of the punch shoe, right? This is our punch shoe. So let's set it to 70 for now, okay? Because I'm going to use 10 mm bolting right here. So when it's end its position, reach its final position, there should be a gap of at least 10 mm. And there is a gap of 19 mm. So this is perfectly fine. Now, there is one more problem, and this problem is very serious. Let me show you what is the problem. Let's say initially the seat is over the die tip and over this blank holder, right? And punches start forming the seat and it reaches its end position, something like this, right? Now, when the die begin to go back to its initial position at the top, the blank holder will also start to go up because it's supported by the gas springs, right? But there is no part left over the blank holder. So the final component will left here, okay? It will not goes up with the blank holder. So when our die completely take off, our blank holder will reach its initial condition and our final product will be remains inside the punch and this blank holder, and it will be very difficult to collect the final part, right? So we will have to make sure that some part of the final product after the drawing remains over the blank holder. And the part that we can leave over the blank holder is the seat which is not formed. So let me go to the sketch of this portion, and this is 10.8. So we can go for 10 mm. Okay, we can reduce the diameter of punch up to 10 mm. Let's just decrease the 5 mm. So go back to our assembly and let's open the punch and let's reduce the diameter by 10 mm. 5 mm is the radius, 5 mm on the both sides. Okay, so now it's 190 mm. We also need to decrease the diameter of our punch shoe to 190 mm, and we can and we have to also decrease the diameter of the blank holder and blank holder shoe, right, to 190 mm. Now, as you can see, when the drawing process will be finished, some portion of the final product will remains over the blank holder. So when the die will be goes up, take off, right, the blank holder will start coming up, and this will also bring the component. And when this will be completely take off and our blank holder will reach there, the product will be over the blank holder. So to simulate this, what we can do is, let me set our final product to float. And to do that, first I will have to suppress the constraint that I have made with the planes, right? So let me suppress them or delete them and set this base plate to fixed, because this base plate is going to be fixed, right? And now also let me suppress this mate and let's bring this and let's mate this with the blank holder. So now initially there will be no product. So initially our die will be at top, right? And our blank holder will be somewhere here, guided with the punch. Or if you want, we can increase the height up to 60 mm to properly guide it with the punch. We will place our blank size into the cavity of the blank holder. I don't know, I'm not being able to select it. Something like this, right? Now, when our die will be come down to form our seat, it will be goes like that, but here it can strike our blank holder. So what we can do, we can reduce the diameter of the outer diameter of the die. So let's reduce it by 5 mm. Okay, that's not the problem. We don't have to fully press the blank size. Okay, now when it start forming the blank seat, so why not let me mate it with that blank holder, right? So yes, now the die will be start forming the blank size, and this blank holder will be goes with the die, and this will be formed like this. And when it will reach its end position, so at this time the blank size is completely deformed in our final product, the container form, something like this. And after completing this process, our die will be take off and it goes up to its daylight position, and our blank holder will goes up because the gas spring is pushing it, and we will get our product over the blank holder. So now everything is set, and let's just try to mount our gas spring. Okay, so how we can mount our gas spring? So there are two options. First option is we can mount its bottom, there is a threaded holes, or we can mount our gas spring with its shoulder. The gas spring shoulders comes with a ring, and we can use a special design of flange to mount the gas spring. And the flange also comes as a standard part. As you can see here, there's a inside cut into the flange so we can mount using our two rings using the solder. So here I would like to mount this gas spring with its solder, and I have already downloaded the CAD model of the flange. So let's first mate it. Now we will have to mount our gas spring over the base plate. I choose to mount with the solder because it will be easier for assembly and disassembly, right? So as much close we can mount our gas spring will be better. So the center distance is 150 approximate, so we can go for 155, and the diameter, the body diameter of the gas spring is 32 mm, 16 mm is the radius. So let's first make the hole and set it to 155, right? And take a circle and set the diameter to 32. We will use a G6, but I would like to go for 32.2 mm. There will be enough clearance to install it. And let's cut this through, and also let's pattern it. Oops, circular pattern. Select the dowel pin diameter and select the feature and set it to 4. Okay, now get back to the assembly. We also need to, and let's first try to mate this. Okay, now if you see, the gas spring is here, and also the mounting hole of the flange is here. So it will be not easy to put the Allen key or tighten the bolt. So what we can do is we can rotate the orientation of the flange, something like this. So we will have enough space for everything, for a gas spring, also for mounting of this flange. So let's also try to make the mounting holes of this flange. So the diameter is M10, I have selected, and the radius I have forgot is 112, right? So let's open it. Now we can mount this with the hole, something like this, right? Now we will also have to add the mounting holes for the gas spring, but I'm not going to do that. It's up to you. If you are following me along, then you can do it. Okay, here what I'm going to do is just pattern the gas spring and its mounting. Okay, so let me select the direction for this flange, and for component let me select it from the tree. So this is the gas spring and this is the gas spring holder, and increase the number to 4 and hit OK. We need to increase the diameter of this blank holder shoe. How much? So we can check the maximum distance between the gas springs, which is 329 something. So why not go for 340 maybe? Okay, you actually don't need to mount or fix this using the bolts with this plate. Okay, because when it will be start pressing, all the gas spring will get pressed up to its last position, up to its end stroke, right? I don't know why it's not working. So first let me mate this with the blank shoes. So everything seems fine, right? This will be initial stage, and when it will be get pressed, this will be our final stage, right? Everything is perfect. Now there is one more thing that I want to show you. So initially there will be our blank over the blank holder, right? And when the die will come down to form it and will start forming, okay? Not at this moment, but when it will reach to the punch, then the forming will start, right? At initially, when it will be goes down with the die, what could be happen is the seat will deform something like this with the radius, something like this, but it could be something like this, right? Is it possible? Yes, it is possible. So how to overcome this? So what we can do in this case is we can use a die cushion, a plate right here, and we can apply a force, a gentle force with a gas spring over this cushioning plate, something like this. So let's first try to create this cushioning plate, okay? So let's say that there will be our blank, right? And if I want to support with a plate over the blank, we will only be able to from here, right? After this point, the radius start, we will not able to support our blank. So the cushioning diameter should be 144, or maybe we can go for 140, right? So let's try to create that part. So go to the part, select a plane, select a circle, and set the diameter to 140 mm. And for thickness, let's select it to 15 mm, and let's save it with name of die cushion, and set the material to mild steel, and let's save it, and let's bring it into the assembly. Now we also need a gas spring. So for the die cushioning, we don't have to calculate the required force. We can just use one gas spring, that will be enough, okay? Because we just need a gentle cushioning. Now we can mount our cushioning plate with our gas spring. So there is a thread of gas spring, and the thread size of this gas spring is M8 because the outer diameter is 32. So this is M8. So let me make a counter hole over this plate of size of M8. So now made this. Also let me concentric it with the die. Now, so let me bring this down up here in a working position. Now, initially this cushioning plate will be here, and when it will be form our final product, and when the die will be completely formed, this should be somewhere here. Now there is no space. And let me tell you one more thing, that if you are thinking this radius, the product final radius right here over this punch tape is controlling by the radius of the die, so this is not true. This radius is completely controlling by the punch radius, not the die radius. If there will be no radius, it doesn't matter, because the moment when it's started forming, all right, so in that case the seat will be something will goes like something like this, right? And as the blank holder will be there, and there is a pressure over the seat, okay, from both top and bottom, so this radius is already made and controlled by the punch radius, right, not the die radius. So what we can do is we can cut our die through something like this. So this will be also easier for manufacturing, and also will be easier for mounting our gas springs and this cushioning plate. So let's try to do it. Let's open our die, and let me select our extrude cut and set it to through all. I got an error of this flit because this is not longer exist here. So let's just delete it and save it, right? And let's back to the assembly. Now what we can do is to mount our gas spring, we can also use a die shoe, something like this, where we can also mount our gas spring and this die too, right? And we will mount our die shoe to our pressing plate with hydraulic cylinder, right? So first let's try to quickly design this die shoe. So let's create a new part and let's and there is a step so we can position our die, right? Now there is a problem. The outer diameter of the die is only 275, so let me set it to 275, right? And if this is only 275, then we don't need to go for 320, we can just set it to 300, right? Now how we can mount our gas spring? So we can also mount in a same way as we have mount this as gas spring on the base plate. So let me take this flange. All right, so this will be our end stroke of the gas spring. So when it will be on the end stroke, our deep drawing should be completed, right? So we have some extra stroke, right? And initially this will be upright here. So first this cushioning plate will press. No, let me show you everything from starting. So first we will place our blank, right? Then our die with cushioning plate will comes down, and now again this is a problem, right? Because first I want the die to hold. We will need to set our cushioning plate somewhere here inside the die, and to do that we can increase the height of the die. So let's increase it to 110 maybe, or why not just make a step here for this mounting, for gas spring mounting, right? Let's measure the diameter of this flange, which is 60 mm, right? So let's open it, and first let's make the hole for the gas spring, that is 32 mm. So let's take it to 32.2 and cut it through, and set this diameter to 70 because 60 mm is the flange diameter, and cut the depth of to 20. We will check it later, okay? And let's try to mate this with the depth, okay? And there is already a mat, so this is giving an error. So first I have to suppress that mat, existing mat. So now it's work fine. So when this gas spring is on the full stroke, there is a too much gap, so let's reduce it. So as this is 19 mm, so what we can do is we can decrease the height, reduce the height by at least 15 mm, right? So now everything seems okay. So what will be happen? So this die will start coming down with extended cushioning plate, right? And it will reach this position, and now when the die will be goes down, this whole thing, blank holder and die will be goes down, and it will be come up to here, and then the forming will be start, okay? And this will be keep pressing on our blank, right? And then this will be start. and finally it will reach the end position where we will get our final product. And after the job done, our die will be get off from here, and our blank plate will lift our final product at the top, and we will able to easily collect our final product, and there will be no longer blank, right? So this is the overall function. Now how about this gas spring and how we can mount this over our pressing plate, right? So what we can do is, we have actually many options, but let's discuss the first option. That is, we can increase the height of this die shoes, something like this, and we can drill it for our gas spring, something like this. But imagine this will be so much heavy and it will consume so much material. So what we can do is, we can add one more plate here, and we can add some pillars, very easy. So let's try to create it something like this. So this was the tool designing for a drawing process. Next, we need to design a hydraulic press to operate this tool, and the first step is to design the hydraulic cylinder. So in next video, we will begin with the hydraulic cylinder sizing calculation for 20-ton press. And then we will go ahead and design the complete hydraulic cylinder with all the seals in SolidWorks. So next videos will be on your screen, or you can check the description. And thank you so much for watching this video.